Okay, welcome, welcome everyone. Welcome to this session. Very warm greetings from Mercy Technologies. So we have been doing programs on trees since quite long. Okay, so we have done the basic approach. How do we represent the trees, and we learned what are the different types of trees, and then we started doing the different kind of traversals. So and then we did some basic questions like what is the height of the tree, count, maximum element, uh, etc etc. So all these were the basic operations for the tree that we have done. So now the question arises like what is the next level or next set of questions that we need to do, or what are the things that are being asked in the interview. So okay, at this point I want to say one thing, guys. Yesterday I was discussing something with my friend. So I was asking like how about the preparation in data structures algorithms, how are you going about it, just a casual question. So like not just he, to summarize what happens whenever somebody asks you this kind of a question, the reason why you learn data structures algorithms is only one thing, guys. Like it's not I'm learning it with passion or something like that. Even though we are not computer science students, we thought that we need to learn this because most of the companies want us to learn this, and they ask this in the interview. So we need to learn that in that perspective only. Okay, there can be so much of theory behind this, but that is a problem with the computer scientists. But actually speaking, like we are learning data structure and algorithms in perspective of interviews. Okay, so I just wanted to say about the weightage. Okay, so we have done from first until this part. Let's say if we summarize, we started from linked list and then stacks, queues, and then we are into trees, right? We have done programs on arrays. Okay, and then I told you there were a few string programs, and string programs can be converted into the character array programs, and they can also be classified into a similar kind of a programs. Okay, so the weightage is like, let's say you go to any company. So the questions they ask is like, it should be 50 percentage to 60 percentage should be covering with linked list. And when I say linked list, then that includes this stacks, queues, and trees as well. It's like 50 to 60 percentage or 70 percentage, so they should be covering this. And if they want to ask some tough question, they'll come to trees part. And like the question there can be some 20 to 30 percentage of chances that the people can ask the question in trees. And if you are really very not lucky enough, or if you feel that you're having tough question, then they'll go to graphs. Okay, so graphs is also not a tough topic, but yeah, it is also a topic that they concentrate on. So if you have a bad day, then they'll be asking you on graphs. And then there comes dynamic programming. And dynamic programming, like that also, it's like I don't say all the product companies ask the questions on this, but most of the product companies ask questions on this. So it's like our preparation should be in terms of the weightage as well, right? So the topics that we have done till now are the ones which are having the most weightage. And if you say that you're coming on, or maybe you're learning whatever I'm teaching till now, then you are actually laying a very good foundation to yourself, because this covers, I think, 60 to 70 percentage of the syllabus part. You have to do even more interview questions. I'll be telling you the approach on what to do or how to do, what should be the approach and all. But just wanted to say that this is how it goes, right? This is how it goes. uh, one thing that I wanted to say at this particular time is, yesterday with the discussion of my friend, I was thinking about it. So it's like, for example, let's say somebody asks you to write about merge sort. Okay, so merge sort is not a big program, right? It's a pretty much easy program, but it becomes easy only when you have already done that question. Okay, it is easy only when you have already learned about that question. Similar is we can say with data structures and algorithms. Like, let's say somebody asks you to write a code to calculate the height of a tree. It may not be that hard, but the thing is, if you have already practiced that question, then then it's like it becomes very easy for you. Similarly, like somebody asks you to write question on selection sort, it is not that hard, but if you do not practice, then it's very hard. So the same goes with any question in data structure algorithms. Actually speaking, in linked list, maybe there will be maximum of 20-30 questions. In stacks and queues, 20-30 questions. And same goes with trees, maybe a 20-30 questions. So actually speaking, there will not be more than 100 or 150 questions. And all these questions only be getting repeated. Say it any product company. Okay. So I'm trying to give you the correct base and telling you what exactly is the process to learn, and perform in the interviews, right? So if we learn this 100 to 150 or nearly 200 questions which are generally asked in interviews, then we are almost done with our preparation. And then the next thing is practice, right? You need to practice this as much as possible. So there is very likely chance that, data structures and algorithms is that kind of a subject where you tend to actually, forget it as the days move forward. Okay. So you should practice. Only when you practice, you are in a good hand. And then later on, this kind of tough questions, when people ask in interviews, you have already done that, right? Then that becomes very easy for you to go and solve. Okay. I just wanted to bring this at this particular point, guys, so that it may give up the confidence or boost. If you are following the class that we have done till now, then almost you are done with, I mean, 50 to 60 percentage of the thing that are being asked in the interview. Last Saturday, I've taken interviews and I covered only until trees, because we are given clear instructions. This ask in data structures algorithms, but not too hard. Don't scare the people, right? So if we should not scare the people, then we should ask only until a particular point where people say, okay, this is a good threshold to stop. Okay. So that's why, like, most of the interviewers keep their threshold to be in trace, or a few people say it's in graphs, right? So taking all this into consideration, right, you just keep practicing. I'll be telling you as we move forward in the classes. So I'll be telling you, after you get a good foundation, how or what is the approach to go and actually practice this 100 to 150 or 200 questions, so that you become very much confident and clear about data structures and algorithms and the corresponding syllabus in the interviews. Okay. So with this point, guys, let me move forward towards agenda of today. I told you that I'll be introducing you to binary search trees. But before going to binary search trees, I thought, like, let me do even few more questions so that the topic becomes even more clear for you. So we'll be doing with the level order traversal today, tree, different types of views. So let's say there is a tree and you are viewing that from top, you are viewing that from bottom, from right, or from left. There will be tree views and you need to print those views, right? So that question we'll be doing. And there is one more question which is least lowest common ancestor. Okay. Lowest common ancestor, I can say the closest common ancestor. This is also one more important question. All the three questions that I've listed down here are very important interview questions. Okay. So level order traversal, that itself is if you have good knowledge on this level order traversal, then itself, like, you can solve a particular set of questions, and you can become more confident on it as well. Okay. So with this point, guys, let me go back and start. Yeah, I'm trying to take an example. What happened? Okay. So I'll take an example, guys. Let's try to summarize what, or maybe try to revise a little bit. Okay. So what is this? This is my example one. Okay. 3, 4, 5. So I just want, there are different traversals we did, right? Pre-order, in order, and then post order. Okay. Can you tell me what is the pre-order for this tree? What is the pre-order for this tree? You can type it. Okay. 1, 2, 3, 4, 5. Good, Lata. 1, 2, 3, 4, 5. Good, 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 everyone. So what about in order? In order. 2 1 3 4 5. Okay. 2 1 3 4 5. That is in order. Is that correct? Is that correct, guys? 2 1 4 3 5. 2 1 4 3 5. Right? 4 3 5. Okay. This is correct. So what about post order? Post order. You're wrong, Naveen. Post order from Lata. 2 3 4 5 1. 2. No. Wrong. 2 4 5 3 1. 2 4 5 3 1. Perfect. You're correct. You're correct. 2 1 4 1 4 5 3 1. 2 4 5 3 1. Yeah, 2 4 5 3 1. That's correct, Rishikesh. I don't know what was done. So 2 4 5 3 1. So you can use the shortcut that we have done, right, guys? So you can use the shortcut that we have done. What is the shortcut that I've done? So we need to take 3 lines like this, right? Like this, like this. So there is one more line over here, something like this. Okay, and then we have one more line. Okay, so just the thing that you need to do is like you need to go as close as to your tree, and you have to draw some line like this, right? You have to draw line as close as to the tree and say, okay, this is how. So in our pre-order, wherever our left line coincides, that becomes our pre-order, and wherever our bottom line or maybe the middle line, that is in order, and wherever our right side line coincides, so that becomes our post order, right? Using this we are able to write something like this. So this is how the pre-order, in order, and post order goes on. Okay, so now let me tell you or introduce you to one more order, which is level order. So which is level order traversal. Level order is nothing but you are traversing level by level. Okay, you are traversing level by level, level by level. So what is the traversal of level by level, guys? It has two constraints. First thing is it goes level by level, and it goes from left to right. Okay, it goes from left to right. So this is how, let's say this is our first level, right? One. Now you come to the next level, which is 2 and 3. 2 comma 3. And now there comes the next level, which is 4 and 5. 4 comma 5. So what are the things? There are two constraints over here. So first thing is we need to print level by level, and then there is one more thing that you need to do. The thing that you need to do is you should come from left to right. Let me take one example. Okay, so it says 1 2 3 4 5 6. Okay, 6, and I say that 7 8. Right, this is my tree, guys. Okay, so I just want you guys to tell me the level order traversal for this one. So you should go from every level and then you should print from left to right. Go from every level and print from left to right. So what is the level order traversal for this? 1 2 3 4 5 6 7 8. Yes, 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 that's it. It is 1 2 3 4 5 6 7 8. Right, I've taken a simple straightforward example. So but this is how you need to get acquainted. Okay, so what it says is start from left and move towards right and print every level. Right, this is your requirement, this is your requirement, and this is how the level order traversal goes on. And maybe let's try to write code for this. Okay, so our code for let me keep this here itself. Our code for pre-order traversal was, how was our pre-order traversal? So we were it was a simple code. So what it says, uh we said public void pre-order, and we are passing root. Okay, so it is of type node, all those things. What we did, if root is equal to null, then what you are trying to do is you're trying to return null, or you're directly returning not doing anything. So so at this time what you're doing, you're printing root. Okay, and then you are saying pre-order of root dot left and pre-order root dot right. Right, this was how simple your pre-order program was. Let me show that to you straight away in the code over here. So what your pre-order program was saying is, the pre-order program was saying something like this. You're trying to write a base condition. After that you're trying to print the root data, and then you are recursively calling for left child and the right child. This was what you were doing, and this was the pattern that we are following for most of our programs, right? Most of our programs. But actually if you see, even if we make use of our recursion also, we cannot straightforward code this, right? We cannot straightforward code this, like, because we need to come back. The recursion, what it says, when you try to call it for left child right child, it tends to move in a different way, right? So we cannot straightforward say that, print level order, etc., etc. So that's the reason we need to write code in a little bit better manner. For example, let's say, even in HackerRank, let me show it to you in HackerRank. Yes. So how it goes in HackerRank. Okay, so where is that? So in HackerRank, the question, or you will be given something like this. Okay, so this is how they say. Okay, so they say print level order, and they'll be giving a root and node. Forget about, I'll be showing you how we are going to write. What I say is, like, they'll be giving us the root and we need to do our level order traversal. Okay, level order traversal, something like this. So what it says, for example, let's say I'm trying to take my uh what do you call, take my method signature to be in this way. So what I say is void print level. Okay, print level of, I say, node root. Okay, node root. So I need to print the level order printing I have to do. So but here one thing that we need to consider is this root is somewhere over here, right? So we will be having all our base conditions, etc., etc., but along with that we are saying that we need to print level by level, right? So what I'll say is, I'll have one more parameter which is int level. Okay, int level. So I'm trying to write code for this one, guys. I'm trying to write code for this one, and just see how we are going to approach for this one, right? How we are going to approach. So it's like I'm saying print level. When I give you a particular level, okay, when I give you a particular level, you try to print that level. Okay, you try to print that level. So the base condition will go something like this: if root is equal to null. So what you should do, you should return, right? Straight away, you need not print anything. There is nothing over here. You need to return, right? So now our next step should become, our next step should become, so I need to print that level, right? I need to print that level. So, right, I need to print that level. So on what basis, right? On what basis should I print that level? Let's let's try to say, in if condition we need to write something, okay? And then what you have to do is system dot, what we have to do is print of what? Root dot data. Okay, you're printing it. So after you print it based on some condition, so what you should do, you should recursively call print level of root dot left, and then print level of root dot right. The same thing that we followed for uh, our pre-order, post-order, and our in-order code. But we were having only one if condition, and the recursion was taking care of everything. But since we need to print level order here, I need to have one more condition which says at this particular level only you print it. Okay, at this particular level only you print it. So in a way, what I'm trying to say is, like, for example, let's say my input is something like this: 2, 3, 4 and 5. Okay, something like this is my input. So what I can say is, for example, in my if condition, so when I call this with root and a particular level, right, and a particular level, I need to print that. So what I'm saying is, so here in my if condition, okay, in my if condition, what I'm trying to do is, if, okay, let me write it here: if level is equal to 1, okay, or I can say 0. Okay, if it is at a particular level, only then you print. Okay, so even though my program is coming to this print level multiple times, only when there is a level of 1 you print it. Okay, only when there is a level of 1 you print it. So that's what my program's intention is, right? For example, let's say, what is this level? This level is 1, and this level is 2, so, and this level is 3, right? So there are different levels. What am I saying is, the once the control comes to my print level program, I need to print it only when the level is 1, right? I need to print it only when the level is 1. So it means, but there are different levels as per the example that we have taken. So actually speaking, with this, what we need to understand is, there should be a program, or there should be something in the main method. Okay, in the main method, so what it says, it should do different things. It should give us the different input. But at the same time, what we have to do is, for int I is equal to 1, i less than so we have to call it for what, guys? For level 1 2 3, right? For level 1 2 3, which means I need to call my print level method for 3 times, or if it is equivalent to the height, right, it is equivalent to the height I less than, one second. Okay, I less than height, I can say I less than equal to height, and say I plus plus. Okay, I say this one. Okay, for int I is equal to 1, I less than equal to height, I plus plus. What am I trying to do is, I'm trying to do this print level of root comma so what should I say is, I should be coming from every I, right? I should say I. This is how your code would work, guys, right? This is how your code would work. So as per the example that we have taken, we should say that every level it should print. But until what point the level should be taken into consideration? Until the height. Okay, until the height. So the same thing that I have done. So I'm trying to traverse from I is equal to 1 until the height, and I'm trying to call this print level. So what is my print level doing? Print level is trying to check, and when the level is equal to 1, it is trying to print the root dot data, right? When the level is equal to 1, it is trying to print the root dot data. But here we need to consider one thing, right? We need to consider one thing. When, for example, let's say I is equal to 3, okay, it came I is equal to 3, and you are saying level is equal to 1 only, then in that case you are trying to print this root dot data, right? So which means there is little bit more tweaking that you need to do for your code. Okay, there is little bit more tweaking that you need to do for your code. So how you're calling this is something that is pretty much important, guys. That is pretty much important. By just looking at this particular code, we will think that it may not work. But the thing is, because of recursion, because of fashion or the beauty of recursion, this code works, right? This code works because we are saying the print level of root dot left and root dot right, and after we are trying to do or call this recursively, our actually our condition will get satisfied, and we'll be printing the root dot data. So I'll be straight away showing you the example for that, guys. Okay, I'll be straight away showing you the example for that. So what it says, where is my level order? Level order. Okay, yeah, this is my level order. So I told you that, let me remove this one. The same code that I explained you is that, so I have something like this print level, right? So I'm trying to do, if root is equal to null, then you return. If level is equal to, here I'm trying to use 0, but maybe I'll try to use 1 over here. Okay, level is equal to 1, then I'm trying to print it. I'm saying level minus 1, level minus 1. Yeah, this is one important thing, guys. This is the actual improvisation that I was saying. Okay. So we did not write this one right here. Sorry. So our method signature is int level, right? So you should be decrementing for every recursive call. You should be decrementing this level minus 1, because only then the recursion works, right? So for every for for your left left subtree, you should do level minus 1, and for your right subtree you should do level minus 1. And this may encounter the the main condition, and finally it will be printing the same thing. Let me show it here. Let me show it in my Eclipse. So what it says, I'm trying to print the level for left subtree and then the right subtree, and finally I'm able to do this, right? Let me do this, guys. Let me do this. One more thing that I did is the same thing that we have done. Search for an element, right? Search for an element. We have taken some tree over here. We have taken some tree over here, and we are trying to do this. We are trying to call the search functionality. Same thing in the level order traversal also. What I did is I've taken a tree, right? I've taken a tree. So here, if you observe, I told you we should be iterating until we get the height. If you remember, we have written the program for this height also. This is our first program entry. So how do we calculate the height and all? This is our first program entry. If you have, maybe if you had practiced, you could have got that as well, right? So we are getting the height just by using the program that we have written, and finally we are iterating until the height becomes equal. Right here I just removed, or I did some tweaking, right? So equal to, okay, so I did something like this, and I'm calling my print level until I start with my for every height of mine. And that is how my level order traversal would be working. Let me remove the unnecessary imports. Now my input is 1 2 3 4 5, something like this. Let me try to run this and say that this is how my code works. 1 2 3 4 5, right? The same thing, you have given me an example, you have given me an answer that the level order traversal for this is 1 2 3 4 5, and we have written some code for this, right? We have written some code for this. The same thing that I have implemented in Eclipse as well, and finally I'm able to print that also. Okay, so let me show that to you again. So we'll be doing the same question in HackerRank also, guys. But this is how we have to do. We came to know that we were not able to straight away code for this one, so that's why we try to analyze for every level. If we do it, then it will be useful for us, right? What we have done is we just modified our main program, saying that after getting the height, we are trying to iterate it over and until at that particular point, and you were able to print it. So if you see the difference of this program to any other program, for example, let's say the height of a binary tree. So what we did is we had a base condition, then we called it recursively, and then after that we had some condition of how to return, right? Same thing, like let's say the number of what do you call the number. So what we did is we had a base condition, right? And then we called recursively for left and right, and then finally we returned something. So here our intention is not to return. So similarly, for example, let's say it is pre-order. Pre-order, what we did, there is some base condition we tried to do, and we tried to call this recursively 2 times, right? Same way for level order also, we had a base condition. After that, this condition is something that is coming to this program newly, that is because of the analysis that we made. And then again we are trying to call this recursively, right? This is how we are calling it recursively. And then for our program to work, we thought that we need to call it for that many number of times which is equal to the height. So that's why in the main program we have introduced this logic, so that our print traversal, for your print, the level order traversal also works, right? So this is how we try to code till now, guys. So with this point, I just wanted to ask, are you able to follow what I'm saying? Level order traversal is also a simple program, guys, similar to what we have done till now. Are you able to follow? We'll be doing the same question in HackerRank as well. Okay. Yes. Perfect. So what I want to say is, like, if you okay, here I want to introduce you to just one more concept. Like, if you see most of the questions that are done in HackerRank or in the discussions or in Stack Overflow or in different places, they use a queue. Okay, they use a queue, and after that they take what do you call, they have their own logic written, and after that they say that either they add something to the queue or remove something to the queue, and then using that they print the level. Okay, here what I want to say is even we also can do that. We can take a queue and and make make the corresponding operations to make the level order traversal work. Maybe I'll tell you that approach as well, but here our intention is to print it. So that's why we do not need to actually take one more data structure which is a queue and try to tweak it to print it, right? So that's why I tried to follow the same approach that we were following till now to every program that we have done, right? To every program that we have done, and finally we were able to print the level order traversal as well. So let me straight away go to HackerRank and start writing the code for that. Okay, or maybe I'll take backup of all this, so that if I go wrong I can refer this code. Okay, so this is my backed up code. Okay, this is my backup code. Let me try to code for this one slowly. Okay, so here this is or I can say yes, this is the original problem statement, guys. Okay, this is my original problem statement. What it says, there is a level order traversal, and I need to do that level order traversal. So if you see, we are only given only this, right? But as per our example, we have taken the method signature to be this, right? It takes a root and it takes level as well. Okay, it takes a root and it takes level as well. So that's why if we need to have one more method, like for example, let's say we are not satisfied with whatever is our level, right? Or whatever is the method that is given to us in HackerRank, if we are not satisfied with this, because we also need one more level, right? So then you can use helper function. Okay, so what is helper function? Helper function is nothing but a function that may be looking the same that is given in a HackerRank or in the code that you're trying to write. But if you want one more parameter, then you can use that helper function. Okay, so now here let me start coding for the level order traversal. What it says, if so what am I saying, if root is equal to null. So what am I saying? I'm trying to say I do not print anything, I will simply return, right? I'm simply returning. That's it. So after I'm done with this, done with my base conditions. So the next conditions. So the next conditions that I write from here is something that that we have done. So what is our next condition, guys? We are saying if level is equal to 1, then only you print, right? Then only you print. But the thing is, you were not able to do it because you do not have this level, right? So you do not have this level. So that's why what is the tweaking that has been done? Maybe I'll show it to you straight away. So what is the tweaking that has been done? The tweaking that has been done is I've taken print level order helper. Okay, I just wanted to take this method convention so that it becomes easier for me to write. Okay, so here I've taken something like this. We have started our code something like something that was given to you. But here what I say is, instead of doing this, instead of doing all this, you need to have a helper as well, right? So which means you need to start writing this code. You need to start writing this code over here, right? Okay, so I started writing this code over here. So what it says, so now I have one more condition, if. So what is my if saying? Now if level is equal to 1, so what I do is system dot out dot print of. So I do something like this, root dot data, and I say that I'll be having something like this, because my sample output says I should be printing 1 2 3 5 6 4 something like this, right? There is a space, right? There is a space between every output, so that's why I'm trying to add one more space over here. Okay, this is my, if level is equal to 1. Now I have to call this method recursively, right? The same thing that I'm calling this recursively. So what it says root dot left, and then one more thing that I want to do is level minus 1, right? And one more way is, like, I should call this recursively once more. So what is this recursive function saying? I should say not left, but it is right. Okay, right, and I'm calling it for level minus 1. So I'm done with this one. Okay, but how is HackerRank written? The HackerRank is written that it straight away calls this level order traversal, right? Level order traversal. So that's why I will try to use my height program, right? Height program. We have done the height program. Let me copy that instead of wasting time to write. So what it says, height. Okay, where is my height? Yeah, height is something here. Let me copy here. This height, we have already done that, guys. Okay, this program, this height program, we have already done that. So let me post it over here. I think I have given that as an assignment also. Same code I started pasting over here. Sorry. Okay, I'm pasting the height program over here. Okay, so now what I say is int height is equal to, I'm calling this method. So what is this? Height of root. Let me maximize this so that it becomes easier to understand. Okay, so I'm calling height is equal to height of root. Okay, now I got it. Now what should I do is, I should write a for loop. So what is my for loop saying? For, so we are implementing whatever we have written in the main method over here, right? What did we implement? Int I is equal to 1, I less than or equal to height. Okay, I'm saying I plus plus. Okay, so after that, what should I call? In my for loop, I should call this one, right? I should call this one. So what it says, I should call. So how should I call? I should pass my root. Okay, I'm passing my root, And one more thing that is expected, is I should be passing the level, right? For every level. So I should pass I, right? I is iterating from I is equal to 1 until the height, right? Something like this. So we are done with our code, guys. So we are done with our code. What we did, so in this method that HackerRank wants us to implement, I straight away used it. And I thought that I should use one more. I need to have one more, which is level. So that's why what I thought is I'd like to have a helper method. So what is my helper method? Print level order helper. I've written something like this. And this helper method is nothing but the one that has one more parameter than that is given to me. So here what I did is I implemented whatever logic we did in our Eclipse code. I did the same thing over here. And this height, we have already done that analysis sometime back in our previous classes. And finally, I'm able to print it by iterating from 1 until the height, right? Let me try to run this code for you, right? Expected, yes, fine. Congratulations, we are done with the compiling of our code, right? Okay, let me submit the code for you. Right, it has passed, yes, super. So it has passed all our test cases as well, right? It has passed all our test cases. And then we were able to see that this is how we can solve the level order traversal of a program, right? Level order traversal of a program. So this might look harder at the initial time, guys, but if you break it down step by step or piece by piece, and if you try to use the principles that you have already learned in your previous classes, then that becomes very easy for you to come and code and make sure that it is running in a proper way. So guys, I just want to ask, are you able to follow the one that I taught you till now? The same thing that we have done in Eclipse, we were able to do the same thing in HackerRank as well. Guys, are you able to? Okay. Yes. Great, Tanmay. Super. So this is how, guys, I told you our approach was to take examples, right? We were taking examples, or we were using the principles that we have already done. And then using those principles, we were able to write codes, right? We were able to write codes. I told you that we can use Q, and using Q, we can do this level order traversing and all. So that also maybe I'll be teaching you. But may not be now, or maybe that's not that greatly useful for us, is what I say. But here what I want to say is, by using the principles, or by using the coding standards that we have that we learned, by making the coding simple, the same process we have applied for a level order traversal as well. But based on our analysis, we found out that straight away we cannot write the code. So that's why we tweaked a bit. Okay, this level order traversal is very important, very important, guys. Okay, mostly, like if they want to ask you some intermediate question in an interview, then they'll ask to implement level order traversal. And when they say level order traversal, you can expect the next question that they're going to ask is something like this. Okay, so let me, if you are clear with whatever we done with level order traversal, so this is our next one. Okay, this is our next one. Maybe I'll be telling you the code, the way we code for this one. But let's see what is the question. So I told you in our agenda there are views, right? Tree views, right? Tree views, right? There is some tree, something like this. So what is my tree? 1, 2, 3, 4, and 5. Okay, there is my tree. Something like this. Okay, so there are 4 views, guys. First thing is, let's say top view, right? What is my top view saying? For example, let's say you're seeing the code from top, or you're seeing the tree from top somewhere. You put your head somewhere like this, and you're trying to view your tree. So what happens is, when you try to view your tree in that way, your top view would become, what will be visible for you is like 2 will be visible, right? And then 1 will be visible. Okay, but 4 will not be visible because 1 is hiding 4, something like this. These both are in the same sequence, right? Something like this, because 1 is hiding 4, so you cannot see 4, right? Again 3 will be visible, right? And then again 5 will be visible. This is my top view. Let's say there is one more thing, which is bottom view. So what is my bottom view saying? For example, let's say I'm seeing some tree in this way. Okay, I'm seeing tree from bottom. Okay, tree from bottom. So what will be visible for me? 2 will be visible, right? 4 will be visible, but 1 will not be visible. The reason is 1 is hidden behind 4. Now 3 will be visible, right? And then 5 will be visible, something like this. Now let's see what is our left view. Okay, what is my left view saying? Left view is something that I'm standing here, I'm seeing my tree in this way. So what will be my left view? Left view is something that, okay, 1 is visible, right? And then 2 is visible. 3 is not visible because 2 is hiding 3, right? This is how they are in the same level. Okay, 2 is visible, 3 is not visible because 2 is hiding 3, right? And then 4, right? 4, but 5 will not be visible, right? 5 will not be visible. Why is 5 not visible? Because it is hidden by 4. This is my left view. Now let's say there is right view. Okay, so what is my right view saying, guys? Right view is something that it says 1, right? 3 will be visible and 2 is hidden behind 3, and then 5 will be visible, right? So these are the different views, guys. These are the different views of a tree. We have taken a simple tree. Why 2 comes first during top view? Okay, order, fine. I understand. You're speaking about the order in which the views are right. So why not 1 comes and why 2 comes, etc. So this depends on the code that we are going to write, Tanmay. So, and again, I did not speak anything specific about the order. I just meant what all are visible. Okay, while we try to write code, then we'll see, right? If you want 1 first and then 2 and then 3, right? What tweaking can you do in your code? But here my actual intention to teach is like what elements are visible. That's it. Okay, what elements are visible. So if I go with the top view, bottom view, left view, and right view, so this is what is visible to me. The thing that I want to say over here is, uh, that since it is a binary tree, it has two children, left and right. There are fair likely chances that one node may be hidden behind another when you're trying to view from any angle, either it is top view, bottom, left, and right, right? So in this, GC, you raised your hand. You want anything? Okay, let me continue. So here there are fair likely chances that one node can be hidden behind another node, right? So that is why we need to cater in our code that we need to make sure in our code that we are taking care of these things. Guys, I think we are running out of time. Let me tell you the theory or the way we can implement this, and maybe we can do code in our next class or in the coming classes. So how we can implement this kind of things, right? How we can implement this kind of things. uh, I just came to know from Kumar sir that you're not done yet with the Java collections, right? You're not done yet with the Java collections, but here if we use Java collections, then it will be easier for you. So maybe I'll tell you a little bit brief about how a collection works. So I want to say about two collections. First thing is what you call map, and the second thing is set. Okay, map is nothing but it is a collection which has a key and a value, right? There is some key and value. And set is also a collection which accepts only unique numbers. So I can say set is something that it accepts only unique numbers. Okay, it accepts only unique numbers. So here what I want to say is, for example, we are trying to write code, write code, and we have taken a example which is there on our right side right now. What I want to say is we are trying to first top view. So when you try to code for a top view, there is something called horizontal distance, guys. There is something called horizontal distance. Horizontal distance is nothing but you're taking your root, right? What is your root? Okay, root horizontal distance will become 0. Okay, root horizontal distance will become 0, and root dot left will have a horizontal distance of root minus 1, right? A horizontal distance of root minus 1, which means 2 has a horizontal distance of, let me take a different color. 2 has a horizontal distance of minus 1, and then 3 has a horizontal distance of plus 1. Okay, plus 1. So similarly, you come to the next thing, right? Now let's say it for this subtree, tree becomes root. And if you want to calculate the horizontal distance for this one, the horizontal distance is root horizontal distance plus 1 for the right child, which is 2. Okay, here when you do minus 1, 1 minus 1, it is 0. Okay, so horizontal distance of 4 is 0, horizontal distance of 5 is 2, horizontal distance of 3 is 1, right? So this is how you can say. What I want to say by taking the concept of horizontal distances, the ones that are having similar horizontal distance, for example, root is having a similar horizontal distance, and then 4 is having a similar horizontal distance, right? So ones that are having similar horizontal distance can be hidden behind the previous ones. The first occurrences can be hidden the previous in the previous ones. So for example, let's say you take nodes based on some, for example, in a map. I told you it will be key and a value pair. So what is my key is nothing but horizontal distance, and the value is your node. Okay, so here if you try to fill this map, for example, so what it says, there is this horizontal distance of minus of 0, let's say, horizontal distance of 0, let's say, and you are having a node which is 1, right? So all this is a map. I mean, I'm taking a very simple naming convention, guess this is not correct, but that's fine, just for you to understand. And now there is one more which is having the horizontal distance of 2 of minus 1, and it is having 2 as its value, and then there is having one more horizontal distance of 1, and it is having 3 as its value. Now you encounter there is one more which is having horizontal distance of 0, guys. But as per map in java, if you get a key which is duplicated, then it replaces the value, right? It replaces the value. So which means you're coming here and say there is this 0 and then 4, right? But previously this key equal 0 was having a value of 1, which means this is overridden, right? This is overridden. And then there'll be a horizontal distance of 2, right? And it is having a value of 5, something like this. We need to start filling a map something like this. And what happens is internally in java, whenever you go for a map, when that map collection sees a similar key, then it gets replaced, right? Then it gets replaced. So with this, what happens is you are able to see these elements, right? You are able to see these elements, 2 and then 3 and then 4 and then 5. So what is this 2 3 4 5, guys? This 2 3 4 5 is nothing but 2 3 4 5 is nothing but a bottom view. Just the order is different, we'll speak about the order later. Okay, 2 3 4 5 is a bottom view. Now I do not want this map concept. I do not want this replacing concept. What I want is the concept of not replacing, the concept of not even allowing a new thing, right? The concept of not even allowing a new a new node if it is already present, right? That is nothing but a set. Okay, same thing I have written over here, right? Set is something that is unique. Okay, So let's say I take a set. This is a map. Okay, this is a map. Okay, I take set and I say that in my set, right, it says 0 comma 1. Okay, and then it says minus 1 comma 2, right, and then it says 1 comma 3. 0 is already coming, it's coming for the fourth time, so I discard this one. Okay, let me not remove this, and I don't even allow this 0 into my collection, so that's why it becomes 2 comma 5. Okay, so this is nothing but a top view. So what is visible? The one that is visible is 1 comma 2 comma 3 comma 5, right? 1 2 3 5. So what is my 1 2 3 5? It's nothing but 1 2 3 5. It's nothing but my top view. Okay, it's nothing but my top view. So whenever you use map, you're getting a bottom view. Whenever you're using set, you're getting a top view. Same thing happens, the same thing happens even for our left and right views, guys. But I just want to leave it here with the theory that we have learned till now. That what we have learned is we'll be taking something like this. We learned about the concept of horizontal distance. Okay, it starts from 0 in the root, and we just minus 1 and do plus 1 for the left and right childs, and we take the base as the horizontal distance of its parent. Okay, so there are fair likely chances that when the horizontal distance is equal, then there are fair likely chances that one element can be hidden behind other. So if your intention is to get a top view, then you should replace the duplicate, right? If your intention is to get the bottom view, then you should not. Okay, if it is a bottom view, then you should replace the duplicate. And if you want to get the top view, then we should not even allow, whenever there is a duplicate which is coming, you should not even allow that to be printed in your top view, right? This is a simple explanation, guys. Maybe I'll put all the explanation, all the theory into code. This will not be complex. Okay, this will not be complex. This is very easy. But just wanted to ask that, did you follow the theory that I told you till now? The theory, or how we are going to achieve this program, did you follow? Guys, did you understand the horizontal distance concept? Yes, that's correct, Rishikesh. And that's what I thought of coming to complex examples later on. If 2 has a right child, then that also will not be visible. Yeah. Okay. So Rishikesh says that that is clear with him. Others, reply fast, guys, so that we can wind up the session. See, if you are not getting it totally, my advice is go back, listen to the recording once more. It's not that hard to understand. That's it. So simple. Okay. So that's what it is, guys. The thing is, like, the problems on trees are not complex, right? We have done the level order traversal program, doing step by step. We were able to print the level order. Okay, so I told you the extension of level order, something, if it is asked in the interview that try to print the level order, then you can assume that your next question could be in one of these views, right? It can be a top view, bottom view, right view, or a left view. Okay, so it can be one of those 4 questions, right? Because this would become an extension. How this becomes an extension, maybe we'll be seeing that in the next class, or maybe I'll get in touch once more with Mr. Kumar and ask him, like, until what point guys are comfortable with collections. So in case, if that is the case, then maybe I'll move forward and take this example, or else maybe as we end towards our course, you'll be having a little bit more grip over the collection API. So I think that would be a correct time. Maybe I'll make myself clear by this day. But thing that I wanted to tell you over here is, like, we are clear with our approach, right? The way we have taken the horizontal distances and then calculating these horizontal distances, and finally we need to make all our understanding into code. That's it. And we should make sure that it is running properly in your Eclipse or in your HackerRank or whatever. But the first thing is you have to do all your homework, all your groundwork to make sure that you are able to write the code, right? So at this point, guys, I just want to wind up today's session. So in case you find it a little bit more difficult to understand, then I advise you go back, hear the recording, and you would be more comfortable. So guys, thank you for the time. Let's meet tomorrow. Bye bye. Have a nice day.